Okay, part 6c says, find the particular solution of the given differential equation with that initial condition. So I remember this box on the golden notes. The particular solution, so up here, it's what we said earlier. You have an equation for finding the slope of a curve. The appearance of that curve is not known. We're trying to find the equation for this curve. That equation is going to be y equals something, or you could think of it as f of x equals something. So I have to use the sassy method. So I have dy dx S stands for separate. The first step is I multiply both sides by dx. Then I'm going to multiply both sides by 1 over y minus 1. Okay, the last problem tricked me. Sassy problems where I'm finding a solution to a differential equation, almost 100% I can get 4 or 5 points for sure without any tricks that they can do. So I like these problems for getting a lot of points fairly quickly. If you get this far, you're going to get the 1 point for separating. Let's put that in blue, I guess. So you get the 1 point for separating if you can get to here. Now we need to do the antiderivatives. They're going to give us 2 points in this case. This requires the expanded ln rule, because this is 1 over 1y minus 1. So the antiderivative is going to be 1 over a multiplied by natural log absolute value of ax, so 1y minus 1. This antiderivative is simply x cubed over 3. And then we have the extra constant. Remember, you only need a constant on one side. That gets you 2 points if you have this written on your paper. So that's 3 points so far. Now we want to find the constant by using the initial condition. That will give us 2 more points. So we write down natural log, we plug in the y value. When x, for this formula we're looking for, when x is 0, y is going to be 3. So plug in 3 for y, 0 for x. The absolute value of 2 would simply be 2. So I've now found the value of c. If you have this green information, you get 2 more points. You wouldn't have to have this line here. Once you get to here, if you simply write down c is equal to natural log of 2, you'll get both points. I suppose this is the point here for finding the constant. The point here is for using the initial condition. So, last thing to do now is isolate the y, which means we're going to take this equation, plug in our c, and go from there. So we have the natural log, absolute value y minus 1 must equal x cubed over 3 plus natural log of 2. On the golden notes, there's a formula that says, we'll write it down over here, e to the natural log of whatever is just the whatever. So we're going to use that formula now. Take both sides of this equation, make them exponents of e. I'd rather have 1/3 times. It's a little easier for me to write. Okay, the ln of 2 has to be up here in the numerator. E to the ln of this is just this. Okay, we can't use a rule here yet. We need another formula that's on the bottom of the golden notes. That formula says e to the a plus b is simply e to the a multiplied by e to the b. So this becomes e to the 1/3 x cubed multiplied by e to the ln of 2. But e to the ln of 2 is just 2. So now we have absolute value, y subtract 1 is equal to 2 e to the 1/3 x cubed. To get rid of the absolute value bars, you consider two possible solutions. It is possible that y subtract 1 might equal this as is. It is also possible that y subtract 1 could equal all of this on the right multiplied by a -1. Let's rewrite that, it's a little easier to see. Having trouble with the board, sorry. So -1. We check by using the initial condition. When we plug in x equals 0, we're supposed to get a 3. If I put a 0 here, this will be e to the 0, which is 1, multiplied by 2. If you add the 1 across, you'd get 3. So this is the correct answer. This would not work, because this would become -2 plus 1 would be -1. So cross that out. So summarizing again, if you get the blue right here, you don't need that antiderivative sign. I should have had one on both sides. If you get to here without the antiderivative sign, that's 1 point. If you get this line, both sides correct, that's 2 more points. If one side is correct, you'd get 1 of the 2 points. If you don't have this correct, you can't get the rest of the points really. So you just lose the rest. But if you get to here and then you plug in the initial condition, that's a 4th point. If you then write c equals ln of 2, that's a 5th point. If you go on to find this, that's the 6th point.